So we're looking at, we're looking at the notes here. These are chapter 3 notes, and it's about addressing. It's all about addressing. So we've got layers of addressing. We've got, and a little bit of this is, I did go through a few of these slides, so I'm going to go through it again. The words will be different this time because they're always different. But the addressing, the idea here is we have many layers of addressing, which more or less reflect the OSI model layers, but starting from layer 2. And today we're going to be looking at addressing in layers 2, 3, 4, and a little bit in the upper layer there of application. So MAC addressing, that's addressing at level 2. That's a physical address. Remember, that's an address that is on each device. When I say on each device, it's on the interface of each device. So if you have a computer, you're going to have a Ethernet connector. There'll be a address there. Perhaps a different address on the wireless address, radio. Okay. If you got a switch, you're going to have MAC addresses for each one of the ports. If you've got a router, you're going to have a different MAC address for a port. So your MAC address is an address for the device. It's addressed to access the device. And so that's why you can have more than one on certain devices. If you've got a device that only ever accesses a network one way, well, maybe it'll only have one MAC. So we put a MAC address on this thing that we call a network card. TCP/IP, that is a set of protocols, but TCP/IP gives us the IP address, and we'll be talking about that. Now, when we talk about ports and sockets is because when we want to use the address in the transport layer, when we want to use the protocols of the transport layer, we need to use a port. But when we marry that port to a IP address, then the IP address and the port together, that's called a socket. Domain names, we have this thing called a DNS, domain name server. Domains are the network components, including the networks out there in the internet. And so you will see, on looking at it on a global way, how we use naming for domains. And some command line tools. Now, actually, there's a lot of slides here about using things in Linux, and I'm not going to really spend too much time on that. We'll go over those kind of quickly, I think. So the data link layer, that's the MAC address. The MAC address, I hope that's familiar to you. It has 48 bits, 6 lots of hex numbers. The hex numbers are two hex numbers together. Or big hex number if you want to look at it that way, but 48 bits. Each of those, so 6, each of those is going to be 8 bits. Also called a physical address. Network layer is IP. There's 2 different types of IP, IP4 and IP6. IP4 is the smaller one. That's the one that we've been using since the internet started. IP6 was developed because the one we're using doesn't have enough for the anticipated usage. And so we developed the IP6. That's actually built into the operating systems that we use. You can use IP4 and IP6. Transport layer port numbers, we'll talk about those. Fully qualified domain names, and I did mention this last time, so I'm going to go over that. I'm just trying to stress the things that I might not have covered in detail. So the MAC address has 2 parts. First part is going to be about the manufacturer, and then the second part is going to give you an address. Remember, the MAC address is that big address with 48 bits. The picture there is just to show you a network interface. Static and dynamic IP addresses. This really just talks about how you get your IP address assigned to your device. So an IP address is assigned to your device, and it's assigned by the network administrator or by DHCP. The DHCP will have a spectrum or a list of IP addresses that it can assign out to people as they join. And then those IP addresses will be reused when that person gets off, then that IP address is free and somebody else can use it. So DHCP is a more efficient way, I guess you could say. You don't need to have as many IP addresses to get as many people on the network. And remember, a minute ago, I told you that IP version 4, we don't have enough addresses for the whole world. And so we're using all kinds of little tricks to get more use out of the few addresses that we have. One of those tricks is DHCP. Right, so yeah, Windows 10 has, you can update your TCP/IP settings in Windows 10 if you go to your network settings. Maybe we'll have a look at that when we're finished talking about the slides here. The idea of a gateway. So we have an interface between us and the outside world or some other network. That's going to be a gateway. So by default, that will be a port on a router, because routers make the interface between networks. Subnet mask, that's going to indicate which IP addresses are available in this little part of the network. We'll be using subnet masking quite a bit later on. DNS servers. One of the problems that we have on our network is that we as human beings, we don't think in terms of IP addresses too much. The computer doesn't think in terms of names. So we think in terms of names, and the computer thinks in terms of IP addresses. The DNS server is able to sort of hold a database of names and IP addresses, and it's able to match them up. So when we ask the server for Amazon.com, it's able to look up in its database, Amazon.com is this IP address, and so it can give it to us. So a DNS server is, if you don't have that working, you probably won't be able to use the internet because you'll be trying to use URLs and it just doesn't know what they're doing, what it is. As I said, two different types of IP addresses and so this is a version 4 IP address, and it's got the 4 octets, and so a total of 32 bits. Now we talk about classful and classless addressing. Classful addressing means that we specifically set the address using the ranges which are identified by a theory of A, B, C, D, E kind of thing, right? So A addresses, that actually takes up, we're looking at the first octet. The first octet numbers from 0 to 126, that's our A addresses. Our B addresses go from 128 to 190, and then our C addresses go from 192 to it's either 224 or 240, but each case we get half as many in the first octet, but we get many more in the other octets because we're able to use the other octets. So there is also mentioned here some private addresses. So this address here at the bottom should be very familiar too, but also the 10, right? If you are working on your own network, a private network, the defaults are that we're always going to use, well, not always, but we typically use 192.168 as our for our private addresses and our networks that we're building. All right, so as I mentioned, A is going to be addresses from 1 to 126, and that only is going to give you 126 networks. So the organizations that have IP addresses that start with somewhere between 1 and 126, those are going to be big organizations, maybe something as big as the American government or something like that. The thing is that those organizations have lots and lots of, not just users of them, but they have lots and lots of devices, nodes within that network that are their equipment. And so they might need all those IP addresses. Look, it's possible with an A-class address to have 16 million devices as part of that network. With our B-class, we have a smaller number, still large, 65,000. That's going to be addresses that start somewhere between 128 and 191. And so with the A-class addresses, the only thing that we're changing is the A. They have millions. A-class has millions of users. This one has 65,000. Now, C-class, that's what we tend to work with. We'll be given a private network, and we can work with, or we'll be given a IP address by our IP provider, and it'll be somewhere in the range between 192 and 224, as 223. And so with those, for each individual network, for our network, we'll have like 254 nodes we could put in that network. That's not so great if we have a bigger company, and so we might have to do something about that. And so we have ways of managing that. I mentioned a minute ago, classless. And so we can apply classless networking to get more than 254 nodes in our network. And D and E, these are kind of experimental and special. Anything that starts with a number bigger than 224, anything from 224 up to 254, those are going to be special. And so as it says there for multicasting, multicasting is where you're sending out special messages to more than one device. Anything over 240 is just for like research areas, research on networking, but not like university research. So I mentioned a minute ago that we have this problem. We don't have enough IP addresses for version 4. So we've come up with a few different ways of doing that. One, to sort of get more addresses out of the limited addresses that we have. One is NAT. The idea of NAT is that within the network, we have our private IP addresses, and then at the applied on the router itself, we have a software which is able to translate that IP address on the inside of the network to a different IP address, which is shown to the outside world. PIT is similar to NAT, but the idea there is that we add another number to it, which we'll call the port. And the port actually is talking about a particular service that's on that device only. And so that's why it's a transport layer. So that's putting together a transport layer and a internet layer in a single number. Remember, this is all about addressing. And this, I'm pretty sure I showed you this in the previous lesson, but just to get it there again, the port addresses are added to the IP addresses because to indicate that what service that we're kind of using for those devices. And so together, the port address plus the, so look at this, all right? So the gateway has this IP address, the number, okay, inside the network, we've got these addresses. These are private networks. These guys out here that are accessing it through the gateway, they can't see these addresses. And so the only address they can see is 92.51.44.1. So what we do is we translate. So we got some software on the router that's going to translate that number, 120, 121, etc. And how it's going to translate that is by adding a port address to them. I hope that makes sense. Sorry, the gateway is a router. Yeah, you can tell a router this symbol. This is a symbol for a router. With two, it's a cylinder with 2 arrows going out and 2 arrows going in. That's a router. Okay, so with our NAT, which is the network private addressing, right? Network address translation. What's happening there is we can have that in a couple of different ways, right? So we could have that that's going to be installed on the router, as we said. With static, what it's going to be is that number is going to be the same every time we use it. That's what we mean by static. With dynamic, that means those numbers can change depending on the access point and how it's accessed. So we have a pool of public addresses which are assigned as required. All right, so a little bit there about the IP version 6. Not going to talk about that too much because I did just introduce it briefly last time, and yeah, not too much. We do have this term dual stacked. I don't think I mentioned that last time, that on your computer, on anything that's running Windows, sorry, Microsoft operating system, you're going to have the ability to use both IP version 6 and IP version 4. Now, there's two ways that the IP version 6 can be composed, and you can see them here. You can compose it as a global address, and that way, so remember, it's got the 128 bits. If it's a global address, the first 3 bits are used up there to identify, what is that? The first 3 bits are going to be for global unicast, right? And then we've got a routing prefix, subnet, and the interface idea. That makes up the 128 bits. If, on the other hand, if we're using a link local address, the first 64 bits are going to be this thing that's called FE80/64, which is going to be created for you by your network operating system before you create the IP address. This IP address might be something which is short-lived. I do remember we talked about that last time. This number, I just mentioned that, right? If you're going to do a local, then we have this address prefix, which we call FE80/64. That's not just a random thing. FE80 doesn't, it's not some special thing that means anything other than the hexadecimal number. So what this is that's a 15 and a 14. Okay, so it's the hexadecimal number in the prefix. So if you go back and look at the prefix here, this prefix here, the first 4 things, that's an F. Then the next 4, that's an E. Okay, so you get the idea. And then the next one, I guess, is an 80, and then the 64. So this FE80/64 refers to this string of 1s and 0s, which it becomes the first 64 bits of that address, that IP address that we use for a local link. All right, so the idea here is that is generated automatically. So what happens is the computer is actually going to create the first 4, that FE80/64. That's going to be created by the computer for you automatically. Then the last 64 bits, let's go back to that, the last 64 bits. So automatically, going back, this thing is created automatically, this part here. And then the last bit is going to be generated randomly by the computer system. So when I say the computer, we're talking about the network operating system here, right? That's going to randomly generate the other numbers. And then the computer is going to check to see that that number hasn't been used before. In other words, so it's unique. And if it is, then it can be assigned, and away you go. You've got your IP address randomly generated in real time IP address for you by your operating system. Okay. A minute ago, we talked about ports and sockets. Ports are used by TCP and UDP, which are transport layer protocols. The socket is when you combine the port address with the IP address of the device. So we have a standard way of doing that. So the numbers are not just assigned randomly. There's a bunch of numbers between 0 and 123, which are basically fixed and assigned for certain things. So for example, I think it mentioned there a minute ago that 80 would be the number for a web server. And I think 25 would be a number for receiving email. And so, so there's some of these numbers, they're used for specific things. On the other hand, these numbers here that the private port numbers, there's a bunch of numbers that you as a programmer or whatever, you can just generate these numbers, and they are called ephemeral. Ephemeral means doesn't live long. So they're numbers that just for a single connection, a few minutes or whatever, as long as you're connecting, you got that port number. So you'll connect this port number, maybe you'll one of these numbers in between here to a number like 80 or 25, just to do a particular job. And then, dynamic. Yeah. And so here's kind of showing that, right? So Telnet is so what we can see from this diagram is that Telnet, which is a service, Telnet is a service which allows you to remotely access a computer from another site. And actually, when you set up your networks, a lot of your networks, one of the things that you'll do is you'll disable Telnet. And that's a security feature, right? Because you don't want people just sort of coming in using port 23 if they find out what the IP address is, and then they're going to use port 23 as, as a socket, and they're in, right? Then what are they going to do? Mess everything up. So use Telnet sort of carefully, but it will be using port 23. Port 23, remember, it's not a physical address. Port 23 is just a number that we use to access these protocols in TCP or UDP. So here's a bunch of other protocols that are used at as it says, that layer of application layer, etc., which may not be included in that port. Now, the next thing we need to talk about is these domain names. We got this cool sort of acronym here, FQDN, fully qualified domain name. Okay. And then we have a top level domain. The idea here, so the top level domain is going to be, something like edu, or actually, because everything outside the United States, it's going to have the country as the top level domain. But below that, we have edu, com, org. Anyways, we'll look at those in a minute. Now, the actual domain names are somewhat organized, I guess you could say. There's this organization called ICANN, which you have to apply to them to get a domain name. So if you want to have your own website with your own domain name, you will apply to it. And there's some that are not really easy to get. So for example, you and me, we can't just go to a web provider and say, okay, I want a domain name markfloden.arpa or markfloden.m or markfloden.int. And they're not going to give it to me, right? Because those are restricted. Markfloden.edu, those are restricted as well, or gov. But if I wanted markfloden.org or markfloden.com, I could probably get that. And yeah. And so this is what we're talking about, the TLDs, the top level domains. Oh. Don't die on me. Yeah, there we go. Right. Yeah, the top level domains, as I mentioned, org and com, they're pretty much open, and so is info. Network is going to be used by Arito, but these others are kind of gov, edu, ARPA, mil. They're not really for us to use. They're for special people, I suppose. So the DNS, I tried to explain in my way a minute ago. What the DNS does is it is able to translate a URL, universal resource locator, which is into something which is going to be IP address, so that you can actually access a different machine. And so you need a server to do that. The server is going to hold a database that allows you to do that. You could also have some software on your client that works with the server to get that information, which we were calling here a resolver. So in your own organization, you're going to have some DNS, maybe a DNS server locally, and maybe that'll have a cache with it. And then it will also communicate with a DNS server remotely. So what do we got? We got 4 different types of DNS servers. As it says there, we're going to have an authoritative DNS database for the organization, which is basically going to have a map of all of the main nodes in your organization. When I say a map, the mapping is just going to be the node to the IP address. Then you can have a backup with it. Now, when you want to connect to the internet, you need to use their DNS server as well, right? So we need to know our DNS server, but we need to know their DNS server too. When you connect to Arito, one of the things that you'll do is you have to have their DNS server. Now, they usually give that to you, but you could talk to somebody in Arito, they could tell you what that server address is as well. Caching server makes your connections a little faster. So what the cache is going to do is every time you access a device using the server to resolve that, you're going to store that information on the cache. And so when you want to try and find something, you can just go to the cache, and if you've been using that a lot, the cache will deliver up to you the information a lot faster. And yes, you can have more than one type of server on a single machine. So this is what we mean by the top level domain servers, edu, etc. And then below those, we can have our authoritative servers, and then we're going to have individual servers below those. What we're doing here in this diagram is we're trying to show that we're trying to resolve a name using the DNS server. So your client computer is going to access the local DNS server. If the local DNS server has that map, because maybe what you're trying to do is get something that's local, then it will return it to you. But if it doesn't, then it can go to the root DNS name server and check there. And if that doesn't, then it will go to the top level domain server and check there. And if that doesn't, then it'll go to the authoritative domain server, and you should get your IP address that way. So you've got kind of levels, kind of like a hierarchy, I guess you could say. Okay, we'll go here first, we'll check that. If not, then that, then that. And each of these might have a cache with them. With the requests, I guess I'm just going to go down to that. We have recursive or iterative. We can demand that we get an answer for our request for the address. And so recursive, what it will do, it will give you an answer. It'll either be here it is, or it'll say that doesn't exist, kind of thing. It cannot be found. Or another way of doing it, which is a little quicker, is we just do iterative, and it'll just check the local servers. And if it doesn't find it, yeah, well, there's no demand that you have to tell. So lucky if you do, but if you don't, you don't. So things that are stored in a DNS database, as it says there, we got name address mapping. I was talking to you about that. Name address and IP address with IP version 6. So A and 4 A's, a C name, canonical name, holds alternate names for the host. So we can have different levels of information about the host that's being stored in the DNS server. But remember, overall, the DNS server is about mapping what you're trying to look for with a IP address. This just talks about 2 different types of software that are available to install and run those as your DNS. So this is a pretty popular one. It says it's the most popular one has been Berkeley Internet Name Domain, but Microsoft also has its own DNS software, which it's going to run on its Windows server. Yeah. Now it talks here about making things a bit more secure. We don't want people from the outside to be able to search through our DNS server and find out what all of the nodes in our network are. That would be kind of bad. And so we try to isolate things. That's what we mean by DMZ or DMZ, depending on your demilitarized zone. I don't know why they call it that, but they've called it that forever. So you see 2 firewalls, and in between them, we have a server, and that server is in the DMZ. So this is our private network here on the right. And that private network has our own internal DNS, and this is running Windows, so it's got Active Directory running on that. And we have a firewall, which separates us from the external DNS. And then that device is separated again by another firewall to the internet. And so between those 2 firewalls, we call that the DMZ. We can put our external DNS there, and we don't have to worry about people sort of coming in and breaking into our own internal DNS if they want to find out things about our network. They'll be able to get enough out of that. All right, so can I in a minute, I'll show you this. If you just in your tools, from your start menu, you can pull up this and it'll tell you about things that you've been doing on your computer and things that have gone wrong. You can actually search that to see what kind of things might have happened with your DNS as well. We'll look at that in a minute. You have from the command, we'll look at this in a minute too. We won't do all of these, but we'll do ping and IP config. We can't do Ifconfig. We could do NSLookup, but we can't do Ifconfig and dig because they're only for Windows. But ping and ipconfig we can do. These are little tools that we can run off of the command line, which can give us some information that might be useful to us. So there's a little bit about ping. I don't know if you've heard of ping before, but it's just sending a few packets across the network to a targeted device. And if those packets come back within a certain time, that means that we've got a decent connection. So that's the idea of ping, is just to see, is our network connected? And so that's what those things all mean. Have we installed the network? Is it configured properly? Is it connected, basically? And so we have these special small ICMP packets that are sent across, and they allow us to do that. We'll look at that. I'm not going to do the ping 6. We'll do a ping 4 in a minute. But as it says there, we can run this on Linux as well, but also on Windows computers. You can ping as well, right? I mean, this kind of looks kind of small. This is just showing you what a ping looks like and how when it was successful. We can do that ourselves. And this is showing you what an IP config shows. What's cool about the IP config is it actually tells you what is your IP address on the network at the moment. And so that's kind of useful. And so we'll look at that in a second, I hope. Okay, so a little bit more on that. Ifconfig. I'm not going to talk about these too much because I don't have Linux here to test it. Maybe you guys, if you're going to do some more networking, you'll definitely be doing Linux courses. And so you'll be using these. What you'll find is that the Linux commands, they're a little bit more useful than the Windows ones. Not sure why that is, but it seems to be that way. They provide a little bit more information. NSLookup, we can look at that in a minute. There's a lot of sort of subcommands that go with NSLookup. We'll just look at it in a sort of raw form in a minute. Let's have a look at that in a minute as well. We can see something there. Yeah, there's a bit more about NSLookup. Dig, as I said, dig is going to be like NSLookup, but it works on Linux and Mac operating system, because the Mac operating system is actually kind of related to Linux and Unix. It was built off the Unix platform. There's some other things that we can do. I didn't get this one working on my computer, so I'm not going to spend a lot of time on it. Sometimes DHCP doesn't work. So if it doesn't work, maybe you need to go and do some checking on the server. And there is some configuration that you can work on. The lease time is how long is it until, how long does the user get to use that IP address? Now, if they're using it, you know what I mean, they're sending data, the way that lease time works is that as long as they're being active, they'll be able to keep their IP address. But if, you know, they turn on the computer and they access the network and then they go and walk away and go and have lunch, well, the lease time, if it's 20 minutes, you know, at 10 minutes, still the server will try and contact that device and see if it gets a response. If it doesn't, it'll drop the connection. So the idea of that, so having a shorter lease time would mean that we wouldn't have lots of not working, quiet, what do you say, sleeping computers connected to the network using up all of our PHP addresses. So that's the idea there. So here's some more connection issues. You'll find that there's a lot of these things. And so in order to solve these things, it would be really good if you could work on the configurations of your devices on the network. And you'll be spending a lot of time in this course that you do in your degree in learning how to do that efficiently. There we go. We're to the end now. In the notes, it didn't refer to IAN. It referred to ICANN, but basically same idea. Assigning addresses. MAC addresses are made up of more than one thing. Yeah, MAC addresses are assigned to all of our network interfaces. IP addresses, the nodes in the network. They also identify the actual hosts as well. Remember, nodes are the parts of the network